TCP, UTP, all can be supported by both. Data rate is 100 Mbps as you can see for FDDI, while Token Ring is available in 3 versions, 4, 16 or 100 Mbps. Maximum frame size is almost same for 4 Mbps, while it is 16 or 100 Mbps. The maximum frame limitation is 18,200 bytes. Clocking is distributed while it is centralized. Capacity allocation, it is based on priority and reservation bits as we have seen earlier. Here it is based on a timed token rotation. We will see how does it work. Okay, we will also do a numerical on it. Token release, release after transmit, release after receiving the entire frame or the leading edge of the frame reaches back to the transmitting station, then only a token is released, right? So if we see the MAC protocol comparison, ETR option is adopted by FDDI, which was optional in Token Ring. What was ETR? Early token release. Because in early token release, what was the disadvantage? Because the token was released once the leading edge of the frame reaches back, rather than the entire frame is absorbed by the transmitting station. So what happens? The station fails to view the reservation bits and releases the token at the previously used labels, right? So this creates a so it partially disables the your this priority scheme, right? So flipping of a bit to change a free token to busy token is not used in FDDI. So this was the case. Station issuing a token can't see PPP and RRR bits of frame control. This is the MAC frame for FDDI, right? This is the MAC frame for FDDI. Here you can see that there is a preamble. Preamble is just like you have seen in Token Ring, that it is a known data symbols, a sequence of known data symbols used basically for synchronization purposes. Star delimiter is also for synchronization. Okay, preamble is just alternate bit pattern, sorry, just the beginning of a frame, marking the beginning of a frame, because it is necessary for the transmitter and the receiver to be synchronized, right? Because here we are using a distributed clocking. So SD, APC, SD star delimiter, as you know that it is a non-data symbols, right? Then APC, you can see frame control, C, L, FF, Z, Z, Z. These are the control bits. FF indicates whether it is a control frame or a data frame. So if it is 00, it is a control frame, right? Or if it is a 01, it is a data frame. So it basically differentiates between a control or a data frame. And C stands for synchronous frames or asynchronous frames, and L says about the length of the frame, right? So and this is a token frame format: preamble, SD, FC, and ED. ED is end delimiter. Once again, there will be a set of non-data symbols, right? Frame status, so destination address, source address, it is of 16 or 48 bits. Information data, that is 0. FCS is a frame check sequence to detect error in a frame. Frame status basically says about whether the station is active, non-exist, So address not found, not copied, address found but not copied, address found, it is copied, right? To say the frame status. Now, coming to the most important and effective thing of the FDDI, that see FDDI works at a very higher data rate like 100 Mbps, right? So as I told you earlier also, there are two types of traffics, streamy traffic and busty traffic, right? So how the capacity of the link, the total capacity link is allocated to both kinds of stations, because basically there are different types of stations having different types of needs. So as compared to the token ring, you can see that it supports for multi-frame dialog. Multi-frame dialog means at the same time station can send multiple frames, and it also supports for a mixture of stream and busty traffic. So there are two type of traffics. We can say streamy traffic means it is a kind of a synchronous traffic, and busty traffic means which you cannot predict when it will be there, when it will not be there. So we have characterized it as an asynchronous traffic. So it is like, you should understand that suppose you have been given the computer or the internet for 1 hour, right? So you have been told that or a child has been given a computer for 1 hour, and it has been told to the child that first of all he or she has to finish the homework, right? And rest of the time he or she can play a game. So it is like that. First of all, depending on the amount of homework, right? If the child has homework in all the subjects, obviously it will take much time for the homework to be finished. So it is said that you have to, if time is short, okay, you have to give importance to the homework. Okay, if the time is short, if the homework is more, means you have to first finish your homework. Then if there is no time, you cannot play the video game, right? You cannot play the online game. But if the time is there, you can play the game. Or if sufficient time is there, when the homework is less, you can do the homework as well as you can play the games, right? So here the total capacity, okay, each station is allocated a portion of total capacity. Please understand it carefully, because a numerical will definitely come if it is an end semester examination. ठीक है, ऐसे बाकी क्विज में भी आएगा, वो अलग चीज है, लेकिन पूरा न्यूमेरिकल आपका क्विज में भी क्विज में एक छोटा पोर्शन आ सकता है, और एंड सेमेस्टर में पूरा क्वेश्चन आ सकता है. तो अगर नहीं समझोगे तो आप समझ नहीं पाओगे अकेले से. So each station is allocated a portion of total capacity. This portion may be zero also, depending on the things. मान लो अगर सारे स्टेशंस कोई भी स्ट्रीमी ट्रैफिक सपोर्ट नहीं करते हैं, किसी भी स्टेशन के पास उतना डेटा नहीं है भेजने के लिए, so they can only participate in a their synchronous allocation can be zero also, not necessarily be, it should be some allocation, right? So what is the synchronous allocation I am talking about? The frame which station transmits during the period of time is called synchronous frames. Okay, so any capacity that is allocated but not used is available for transmission of additional frames, referred as asynchronous frames. As I said, if you finish your homework in time, you will be allowed to play the games. But if you are not finishing the homework, you will not be allowed to finish the games. So depending on the time constraint, if a station, there is a token, okay, a token is moving in the ring. A token is moving in the ring, and this token moves in the ring. So depending on, like, some station, the token may get delayed in the network, right? So if the station receives a token well before in time, right, so it has the flexibility to first completes its synchronous allocation. Okay, first it has to send the frames from the synchronous allocation, and once it exhausts its synchronous allocation, because the synchronous allocation, suppose मैंने बोला कि 10 frames आपको भेजने हैं स्टेशन को, so it will send 10 frames from its synchronous allocation, and if it has got a time of 20 seconds, okay, so means if it has got a time of 20 frames, so then the remaining 10 frames it can use for asynchronous traffic to be handled, right? So you will understand it. So how does it work? A target token rotation timer is defined, and each station stores the same value of TTRT. Some or all the stations can be provided a synchronous allocation, which may vary among stations, right? The allocations must be such that the Dmax plus Fmax plus token time plus synchronous allocation of all the stations will be less than TTRT. So a target token rotation timer value will always be higher than what is the Dmax? Propagation time for one complete circuit of the ring. So one complete circuit of the ring means the maximum time that is required to complete one circle of the ring is Dmax, right? Fmax is the time required to transmit a maximum length frame. Okay. Token time, amount of time to transmit a token, to release a token by the station, plus synchronous allocation of all the stations. So a target token rotation means a token should come back within this limit. Okay, so the token rotation time, a target token rotation time, is defined as the maximum of all these, considering all the factors, right? So it will be always higher than that. So by the time our token should reach back to the station. Okay, so if it is either it is reaching early or it is reaching late. So if it is reaching early, the station will send both synchronous frames as well as the asynchronous frame. But if it is reaching late, it will only send the synchronous frames. It will not send the asynchronous frames, right? So all the stations are given the same TTRT value, stores the same TTRT value, and a separately assigned value of synchronous allocation. So each station can be assigned a synchronous allocation, or it cannot be also, right? Depending on in your network, what is the requirement of the station, depending on the need of the stations, it will be decided. So in addition to that, other variables required to be maintained at each station, which are token rotation timer, token holding time, and late counter. Late counter will say that whether the token is late or early. Token holding time is like if a token arrives early, okay, then jitna early wo aata hai, the amount of time the token reaches early, that time goes to the token holding time, and that much frames, asynchronous frames, a station can transmit. It's a bit complex, but you will understand it with the help of an example. It is just followed after this. So each station is initialized with a TTRT set equal to TTRT and late count set to 0. When the timer is enabled, TRT begins to count down. When a station receives a token, its action will depend on whether the token is early or late. If the token is early, TRT will go to TST, TTRT will be transferred to TRT. अगर टोकन अर्ली आ गया तो कितना अर्ली आया है, that is target token rotation timer value will be passed to TST, TTRT will be given to TRT, and it will enable the TRT. Target token rotation TRT क्या है, token rotation timer, so it is every time it is decrementing. Okay, so if the token is late, late counter is incremented by 1. If the TRT expires to 0, it is reset to the TTRT value. Maybe you may not have followed, it went very fast. Let us see with the example. Okay, so wherever you have doubt, please ask me, I will tell you. Maybe The theoretical part you have not followed, but this you can easily follow. So this is an example where we have assumed some of the assumptions we have that the traffic consists of fixed length frames. TTRT value is given as 100 frame times. What is TTRT? Someone can comment what is TTRT? TTRT is the target token rotation timer. Its value is always higher than the Dmax, that is the amount of time propagation delay to cover the complete round of the ring. Dmax plus Fmax. Fmax is the amount of time to release a maximum length frame of 4550 bytes. Then token release time, amount of time to release a token in the ring, plus the synchronous allocation of all the stations. Okay, so TTRT value will be higher than that, right? So TTRT value will be is higher than TTRT is higher, much higher than Dmax, Fmax plus token release time plus synchronous allocation of all the stations, right? इससे ज्यादा टोकन को टाइम लगेगा ही नहीं, ठीक है? So synchronous allocation is defined for each station. We have 4 stations. Okay, station 1, station 2, station 3, station 4, and a synchronous allocation of 20 frame times is given to each station, right? So each station is prepared to send full synchronous allocation and as many asynchronous frames as possible. किस चीज पे डिपेंड करेगा? टोकन पहले आ रहा है या टोकन बाद में आया? When a station receives a token, its action will depend on whether the token is early or late. Okay, so the token token is arriving early or late will determine whether a station will use its only synchronous allocation or both synchronous and asynchronous allocation, right? The total overhead during one complete token circulation is 4 frame times. Okay, so like it is moving from one frame to the other, one station to the other station. Just a minute. So it is like total overhead means जैसे ये स्टेशन 1 है, ओके, यहां से जब ये यहां जा रहा है, इस स्टेशन ने कुछ ट्रांसमिट नहीं किया, ठीक है, तो भी फ्रेम टोकन को पास होने में तो टाइम लगा ना, तो ये यहाँ पे जब अराइवल टाइम इसका ये जो हुआ, तो ये यहाँ पे क्या हुआ, 1 टाइम में पहुंचा, 1 यूनिट ऑफ टाइम में पहुंचा, राइट? तो जैसे अब आप देखो, आई विल से अबाउट दिस, दिस इज 80 मीन्स अराइवल टाइम. हर एक स्टेशन के लिए 4 कॉलम हमने बनाए हैं. अराइवल टाइम, टीआरटी वैल्यू, व्हाट इज टीआरटी? टोकन रोटेशन टाइमर. Okay, and once this timer is enabled, this timer gets decremented by the frame times, right? And once it becomes 0, it is initialized with TTRT value. Okay, जब ये 100 है, जैसे देख रहे हो ना आप, ये हमेशा घट रहा है. जब ये 0 हो जाता है तो फिर से क्या होता है, फिर से TTRT वैल्यू से इनिशियलाइज हो जाता है, राइट? So TRT value is token rotation timer. This is a synchronous allocation. This is asynchronous frames. How many synchronous frames this station has sent? How many asynchronous frames this station has sent? Right? Similarly for the station 2, station 3 and station 4. Now we have also assumed that during the first trip, during the first round, no station has transmitted any frame. ओके, तो आप देखो जैसे अराइवल टाइम क्या है, यहाँ पे 0 है. टीआरटी इज व्हाट? TRT is initialized to the TTRT value, right? तो TRT वैल्यू क्या हो गई? TTRT वैल्यू से इनिशियलाइज होगी. TTRT क्या है? द मैक्सिमम टाइम, right? So as I said during the first round, just to show you, okay, during the first round no station sends any frame. तो synchronous frames भी 0 है, asynchronous भी 0 है. तो अब ये तो रिंग है ना, this is a ring. So once the token moves from station 1 to station 2, it takes 1 unit time. So that is a overhead during one complete token circulation is 4 frame times. 4 frame times means total overhead. 4 स्टेशन है तो हर एक स्टेशन से कितना लग रहा है? 1 फ्रेम का. तो आप देखोगे ना, टोटल घूम के आया तो कितनी बार आया? 4 हो गया ये, राइट? टोटल ओवरहेड ड्यूरिंग वन कंप्लीट टोकन सर्कुलेशन इज 4 frame times, right? Are you following or not?
Yes sir.
तो जैसे इनिशियली आप सोचो कि कोई स्टेशन नहीं ट्रांसमिट किया पहले राउंड में, तो यहाँ पे क्या हुआ? टीआरटी क्या है? टोकन रोटेशन टाइमर विच इज सेट टू द हाईएस्ट वैल्यू. क्योंकि एक रिंग है ना, कितना टाइम मैक्सिमम टोकन को मान लो ये स्टेशन ट्रांसमिट किया स्टेशन 1, तो स्टेशन 1 के पास वापस से टोकन कितनी देर बाद आ सकता है? व्हाट कुड बी द मैक्सिमम वैल्यू ऑफ दैट, right? So we have defined an upper bound on that the TTRT value can be maximum, that will be a frame circulation time in the ring, total propagation delay in the ring plus frame transmission time जितना लग रहा है स्टेशन को ट्रांसमिट करने में, टोकन जनरेट करने में जितना टाइम लग रहा है, एंड द सिंक्रोनस एलोकेशन ऑफ ऑल द स्टेशंस. क्योंकि स्टेशन 1 के पास वापस कब आएगा? स्टेशन 2 ट्रांसमिट कर लेगा, 3 कर लेगा, 4 कर लेगा, देन स्टेशन 1 के पास वापस से आएगा, right? So this is तो ये तो पहले TRT 100 ही रहा क्योंकि अभी टाइमर इनेबल नहीं हुआ. तो यहाँ पे जब ये आया अराइवल टाइम कितना हो गया? 1. टोकन अराइवल टाइम कितना? 1, 2 यूनिट, 3 यूनिट, राइट? अब यहाँ पे देखो तो 4 ओवरहेड हुआ, 4 फ्रेम टाइम्स का ओवरहेड हो गया एक टोटल सर्कुलेशन करके आने में. तो TRT कितना घट गया? TRT को जब आपने इनेबल किया तो आप बताओ टोकन अर्ली आया कि लेट आया? टोटल TRT वैल्यू है 100, ओके, और यहाँ पे टोकन आया 4 पे, तो टोकन पहले आया या बाद में आया?
Early.
अर्ली आया. कितना अर्ली आया? इसको आना था कितनी देर बाद? 100 के बाद, लेकिन आया कब? 4 पे आ गया. सो दैट मीन्स इट इज अर्ली बाई 96 यूनिट्स, राइट?
Yes sir.
So it will first send its synchronous allocation of 20 frames, okay? और जितना जल्दी आ गया वो, जितना जल्दी आ गया उसको हम लोग क्या करते हैं? ये जो TRT वैल्यू जब जितना जल्दी आ जाता है, इफ द टोकन इज अर्ली, TRT को हम लोग ट्रांसफर कर देते हैं टोकन होल्डिंग टाइम में. एंड वॉट एवर इज द वैल्यू ऑफ दिस टोकन होल्डिंग टाइम, दैट मैनी async frames can be sent by the station, right? तो अभी तो आप ये देखो, बाद में हम लोग डिस्कस कर लेंगे. तो सिंक्रोनस एलोकेशन 20 फ्रेम्स का, और जितना जल्दी आ गया टोकन, जितना अर्ली आया टोकन, उतना ही असिंक्रोनस फ्रेम इसने सेंड कर दिया. बात समझ में आ गई? फॉलोड और नॉट?
Yes sir.
तो अब आप बताओ दूसरे स्टेशन पे जब ये आया तो यहाँ पे 121 कैसे हो गया? देखो 4 तो ओवरहेड था ही, प्लस 96 यूनिट अर्ली आया। तो अगर आप देखोगे 96 प्लस 4 100 प्लस 20 120 तो ऐसे ही एग्जॉस्ट हो गया। और एक जो था ओवरहेड फ्रॉम वन स्टेशन टू द अदर स्टेशन, तो 121 में आया। तो अभी टोकन अर्ली आया या लेट आया? लेट आया 20 यूनिट से, राइट। तो इसीलिए यहां पे क्या लगाया? स्टार मार्क इंडिकेटिंग इट इज लेट। लेट आया तो इट कैन ओनली सेंड द synchronous allocation, it is not allowed to send the asynchronous frames, right? So 121 plus 20 141 plus 1 overhead from station 1 to other station, so it is 142. So it is late by 40 units, so it is decremented. This TRT value will keep on decrementing, so it is delayed by 40 units, so it is 60 20, so it can send only sync when it is late, right? 184, so it is late by 80 20 20 sync भेजा। अच्छा अब यहां पे बताओ 205 तो 20 20 यहां पे था ना, और तो 0 हो गया होगा। ये लाइन समझ में आ रही है? कितने लोगों को समझ में आई ये लाइन? यहां तक तो क्लियर है? ये लेट आ रहा है तो सिंक्रोनस फ्रेम्स भेज रहा है, नो असिंक्रोनस फ्रेम्स इट इज सेंडिंग। तो यहाँ पे 184 हो गया, ये 80 यूनिट डिलेड है, सिंक फ्रेम्स भेजा। यहाँ पे 184 प्लस 20 224 प्लस 1 204 प्लस 1 205। बोलो अब आगे बताओ। इसको डिफरेंस देखो कितना है? कितना डिफरेंस है?
84.
84, राइट। तो कितना जल्दी आ गया?
16
यूनिट जल्दी आ गया, राइट। तो 16 यूनिट्स आ गया जल्दी, तो फिर लेट क्यों है ये? बोलो। क्योंकि हम लोग क्या देख रहे हैं? टोटल डिले देख रहे हैं एक स्टेशन पे, ठीक है। इवन दो ये बहुत इंपॉर्टेंट है, प्लीज नोट इट। देखो यहाँ पे 84 यूनिट्स का डिफरेंस है। जनरली एक इसी स्टेशन पे वापस कब आना है? 100 में, लेकिन यहाँ पे ये 84 पे आ गया, तो डिफरेंस कितना है? 16 का, मतलब 16 यूनिट्स अर्ली आया। लेकिन ओवरऑल अगर हम देखें तो यहाँ पे कितना डिले था? 20 यूनिट का ना। तो 16 यूनिट पहले आया, तो अगर हम उसका टोटल accumulated value देखें तो that means it is delayed by 4 units, that is why it is now 96, because ये 0 हो जाएगा, 20 डिक्रीमेंट हो रहा है तो ये 0 हो गया, then it is reinitialized to TTRT value 100 and it is late by 4 units, so it is 96 पे हमने स्टार लगाया हुआ है। followed or not? यहाँ पे देख रहे हो, this is 84, right? but the overall time, ओवरऑल डिले अगर हम देखें, यहाँ पे 20 यूनिट डिले था, यहाँ पे 16 यूनिट पहले आया, तो ओवरऑल डिले कितना रह गया? 4 यूनिट का। और ये क्या है? टीआरटी वैल्यू इज डिक्रीमेंटिंग बाय 20 यूनिट्स एवरी टाइम, ओके, बिकॉज यू विल बी सेंडिंग सिंक फ्रेम्स, so it is decrementing, it is 0, so once it is 0 it is reinitialized to the TTRT value, right? So since it is delayed by 4 units, it is only sync frames it can send, right? So 205 plus 20 plus 1, 226. And if you see, it is again 84, I think. 84. So it is 16 units is early, but it was delayed by 40 units. Okay. So overall, if you see, it will be late by 24 units. Okay. So it can only send syncs. Similarly here also. Can you say this will be followed here? Can you say how it is? It has come over here. कोई भी sync नहीं भेजा ना यहाँ पे. ये बताओ, ये आया समझ में?
Hello.
Hello.
Yes, sir. Sir, in the part where the arrival time is 226, the TRT value.
Yes.
TRT value should be 66, right?
Why?
Delayed by, because the difference is 84 and it was early delayed by 40 units. 84 minus 40 will be 44 units.
84 minus
40.
84 40 नहीं, 16 units early आया. 16 units early आया ना. See, the difference is 84, right? So it has come early by 16 units. So if it is early by 16 units, earlier it was delayed by 40 units. So how much is the time? 14 minus 16 is 24, na? So if you subtract it from 100, what will be value of this 76 unit? Who was asking? I am again explaining. See, the difference is 84, should be 100. So it is early by 16 units. But the overall delay we check for this particular station. So overall delay means earlier it was 40 unit delayed. Now, since it has come 16 units early, so the overall delay will remain 76 because this difference is 24. 100 minus 24 is 76. So it is delayed by this, right? Overall delay will be maintained.
Yes, sir.
Can you say about this?
So, which one?
The last, this
247.
So अगर आप इसको देखोगे, I do not know whether I have not done the complete thing. I will send the scan copy of this. तो जब आप देखोगे ना इसको पूरे इसको, it is not done like that. आप देखोगे station 1, station 2, station 3, station 4. So this capacity allocation of this FDDI is very good. You will find that all the stations will get fair enough opportunity for asynchronous frames as well. ठीक है, जब आप इसको पूरा करोगे, it is only, I have shown only 4 rows, but if you do it, I will send you the complete one. Okay, so once you do the complete thing, you will find that each station will get somewhere opportunity for both synchronous and asynchronous. So it is not like only the synchronous frames are always preferred. Okay, it is even asynchronous frames are also taken care of, right? So stations with asynchronous frames will also get an opportunity for transmission. So it is very fair enough for both kind of traffics to be adjusted in FDDI, right? Any doubt in this? तो जैसे आपको न्यूमेरिकल अगर कोई देते हैं हम लोग, तो क्या करते हैं, हम लोग बोल देते हैं कि सिंक्रोनस एलोकेशन क्या है, टीटीआरटी क्या है, ठीक है, ये सब क्या है आप बताओगे, आपको ऐसे ये करके दिखाना होगा, राइट? हाउ मेनी रोज यू हैव टू डू, दैट वी विल से. So it's very simple. I think, I hope you have understood. And the main objective of FDDI is that the load should be distributed fairly. Okay, each station will get a fair chance to send synchronous, because synchronous every station is sending, even if the token is late. Whenever the token is coming early, each station will transmit asynchronous frames. So you will see that very nicely it is done. So every station will get a fair opportunity for transmission of both sync and async frames, right? So this finishes the MAC protocols, right? And we have seen CDMA and other things, and so you can see this is an IEEE 802 reference model. Actually, this reference model was put to streamline the things, because पहले क्या था कि कुछ भी स्टैंडर्डाइज्ड नहीं था. अभी क्या है, हमारे जितने भी प्रोटोकॉल्स होते हैं स्टैंडर्डाइज्ड होते हैं. ब्लूटूथ है, okay, we all are using Bluetooth, so it is 802.15, we know, and all the devices which are using Bluetooth, whether it is your earphone, your phone, mobile phone, or any other Bluetooth device, they all use the same thing. पहले ऐसा नहीं था. पहले क्या था, कंपनी का मोनोपोली था. ओके, दे विल बी यूजिंग अ सेपरेट थिंग्स फॉर देयर ओन सिस्टम्स, राइट. तो कंपनी मोनोपोली को खत्म करने के लिए this committee was formed to standardize the things for this local area network. Okay, so this committee dictates the standards for local area network. So there are many sub committees of this, like you can see 802.1 network authentication protocol. 802.2 is LLC layer sub functions. 802.3 is your Ethernet LAN, token bus, token ring, wireless LAN. There are many. Okay, I have not written all because 802.15 Bluetooth. Okay, and there are many other improvements are coming in the form of 802.11 A, B, C, D, E, F, G, H, like that. So idea was that only that in an OSI model, this data link layer, already I have told that this is divided into MAC and LLC, and each station is termed as, each point, each user of LLC is termed as service access point. ये भी एक TCP IP और इसका डिफरेंस होता है. OSI में हम लोग उसको क्या बोलते हैं, सर्विस एक्सेस पॉइंट बोलते हैं, right? So it's an LLC user which provides services to the upper layer protocols. I told you the LLC provides three type of services: acknowledged, connectionless, and connection oriented services. Just like your SDLC, some sort of you have studied, and MAC portion we have completed, right? So this is basically the scope of IEEE 802 reference model from the medium to this. So they dictated that this link layer should be divided like this, right? So LLC, which is referred to as a logical link control, okay? It provides three types of services: acknowledged connectionless service, unacknowledged connectionless service, and connection oriented service. तो आप मेरे को बताओगे एग्जांपल्स, कनेक्शन ओरिएंटेड सर्विसेज क्या होती हैं? Can you give any example of connection oriented service? बोलो. आप तीनों का एग्जाम्पल बता सकते हो एक एक? हाँ, क्या भाई बोलो बोलो.
सर कनेक्शन ओरिएंटेड का वॉइस ओवर इंटरनेट प्रोटोकॉल.
Yeah. There can be many examples. Na? Connection oriented means what? You will be using some, like first of all, a connection is to be established. तो उसके लिए आप क्या करते हो? दो यूजर है तो कनेक्शन कैसे एस्टेब्लिश होता है? फर्स्ट यूजर ए इज इंटरेस्टेड इन ओपनिंग ए कनेक्शन विद बी. इट इज जस्ट लाइक एसडीएलसी, अगर आपको याद हो. हाँ, सब में फ्रेम भेजते थे. हाउ द कनेक्शन एस्टेब्लिश्ड गेट एस्टेब्लिश्ड. So connection request is sent. Okay, then if this party agrees to open up a connection, and depending on its engagement, it sends back a connection acknowledgement. Okay, yes, I am ready. इसने hello बोला, उसने भी बोला okay, hi, fine. He also acknowledged, right? Then the data transfer process begins. So any party can award the connection, okay, if they are not interested in further communication. जैसे हमारे टेलीफोन वायर्स, टेलीफोन जो होते थे पुराने लैंडलाइन, हम लोग क्या करते थे? आपने किसी को डायल किया, उसने उठाया, तो आपकी बातचीत शुरू हुई. अगर आपकी बात खत्म हो गई, आपने कनेक्शन क्लोज कर दिया. Once you put the receiver on the hook, the connection gets closed, right? So it can be awarded by any one of them. और so connect this can be दो तरह की. जो आपका कनेक्शन क्लोज भी होता है ना, वो दो तरह का होता है. एक होता है ग्रेजुअल, एक होता है एब्रप्ट. जैसे आपने अपने फ्रेंड को कॉल किया, उसको गुस्सा आ गया किसी बात पे, उसने काट दिया खट से, ठीक है, तो दैट इज एन एब्रप्ट ट्रांसमिशन. ओके, तो अगर हम नेटवर्क के पर्सपेक्टिव में बात करें तो एब्रप्ट ट्रांसमिशन का डिसएडवांटेज क्या है? कोई बता सकता है? बताओ.
सर इंफॉर्मेशन लॉस.
राइट, क्योंकि जो डेटा आपका नेटवर्क में चला गया, राइट, जो डेटा ऑलरेडी नेटवर्क में एग्जिस्ट करता है, वो तो लॉस हो गया ना आपका, वो तो गया काम से. मान लो आप अपनी बात कह ही रहे थे, तब तक अगले ने काट दिया, तो वॉट एवर यू वॉन्टेड टू कन्वे यू कुडंट कन्वे. सिमिलरली वॉट एवर डेटा पैकेट्स ऑलरेडी एग्जिस्ट इन द नेटवर्क, they all are lost, right? So abrupt termination result in loss of data, but so there is a process that is gradual termination. Gradual termination कैसे होता है? One user informs the other user that I am going to be closed, right? I want to close this connection, I'm no longer interested. Then they put the connection in the closed state and continue to exchange data till all the packets which are already there in the network are collected, right? And then once they get all the packets are done from the network, they give a clearance, they give a green signal to close the connection. Then the connection is closed. So it sends an AND request, and once all the packets which are there in the network are taken, then it sends an AND acknowledgement. So AND acknowledgement terminates the connection, right? So this was a connection oriented approach. So this type of connection oriented approach has an advantage and disadvantage. Can you say what kind of advantage and disadvantage? Then we will close this class. बोलो.
एडवांटेज सर इंफॉर्मेशन लॉस नहीं होगा.
Right. So there is a connection oriented means you are very sure that the data transfer will be faster. There is no chances of packet loss, right? You will be getting more reliability and data transfer will be faster. Can you say the disadvantage of this connection oriented approach? See the overhead. आप लोग तो ये सब पढ़ चुके हो. The overhead in establishing a connection. Okay, इसमें आपको connection oriented में कोई आपको acknowledgement नहीं चाहिए, because you know that the data is delivered, right? But in a connection oriented में connection establish करना एक tedious task है, that is time consuming. Okay, because if the two stations are nearby, you can think of, but when there are many things, it is very difficult. right? ये सबको connection request भेजो, then a virtual link is to be established. पढ़ा होगा ना आपने virtual circuit switching. तो virtual circuit switching में क्या होता है? A virtual link between the source and the destination is to be established. Then the data transfer will work, right? So that is very tedious task and involves the resources and time. So it depends on the application where we require more reliability, where we require, okay, koi baat nahi, connection overhead is not a problem because I am going to exchange data for a long period of time, right? So in such scenario, I can go for a connection oriented approach. But if I have to send only a small amount of data and then doing all these tantrums for establishing a connection will not will generate more overhead as compared to the data, right? So that is not advisable to go for this. So okay, then I'm stopping it here. Then kindly join in time, okay, because 10 minutes I'm losing there.
Thank you, sir.
Okay. Thank you, sir.